Hey, my name is Nathaniel. I'm one of the practicing engineers on this project, and this is
Amadou Fofana.
and also,
Alkhabbaz.
all right, and we are working on an instrumentation project. We're clocking GPS speed on drag strip runs. Pause it. All right, this is how you assemble this Pi setup. So what we have is a tablet with a micro board to control the imager, and we have our Raspberry Pi. Going to connect our power supply from this to that. All right, we have our HDMI cable. Let's go from here to here. We have a GPS logger that we will attach over here and plug up to one of the USB 2.0 ports. Following that, we do need a keyboard and a mouse. Luckily, we have them on hand. Gonna plug those into here. And here. All right, and this is a accessory port that helps the tablet out. Not necessarily needed, but that's it.
The power supply.
Yeah, exactly as Amadou said, the last thing that we need is the power supply connected.
To the tablet.
We have a 25 volt power supply, translates to about 4 amps or so. And you see the keyboard and the mouse are powered on. And we have a boot screen. All right, there we go. A little black and white. Welcome to Raspberry Pi Desktop. All right, and then the next step is to install packages for the library. Oh my God, go ahead and stop it, man. After some input errors, you get a yes. Do you want to continue with the first command? You can see the commands on the left. So we're going to install all the data packages and Python scripts needed to do the GPS logging. Now, this may take some time. After this, we will run pip install, then reboot, and install the logger itself. After that, we will work on command procedures, showing how we run a command and then how we end the command, and how data is produced during the footage.
English.
All right, and then the last thing to do is to start finally running our data logger. We need to change the directory to the Pi3 GPS logger. Then, secondly, we need to run our execution command. All right. Set our hertz. GPS is set, but we are unfortunately recording NAN data. We're getting null data for this. We're going to hit Control C to stop, as dictated on the side here. And as you can see, we're not getting consistent data currently out of our data logger. All right, as you can see, we did produce NAN data in this last run. Something must have gone wrong with our hardware, one of our connections, or something with the data logging software. We did try to reinstall the OS and the software from the start, but the initial data we did get was, albeit frugal, yet a little stagnant. So as you can see, we're getting the same result for almost every line out of every data set, and we're thinking we're having a hardware issue here. just to start off with. So, to recap, in our experiment, we were using a Raspberry Pi 4 that was available on hand. We had complications installing a Raspberry Pi 3 OS onto our Raspberry Pi 4, so we adapted the newer code that was provided for the interface. Unfortunately, after we ran 35 to 40 runs with varying setups for both the car and the telemetry system, we came up with ineffective data as mentioned before, as shown previously in those little flips through the Excel files. And although it seems like we've taken, although we've taken an initial log of time, position, etc., it seemed to iterate repetitively the same values, giving us data that we can't quite work with. We have tested all connections in the system. We've tested it with multiple cars, multiple inverters, and multiple power supplies within the car, and we don't seem to get consistent results. Possibly it may be an amperage issue that's supplied by the car or one of the inverters that's not sufficient enough to power the system.